Hello fam! These are solutions to our first Unit 4 review. This is a really good reflection of what you could expect on your Unit 4 exam. This is the same amount of questions that your Unit 4 exam will have. It's the same length, it's the same format, and the difficulty level is about the same. So I would say this is a really good reflection of what to expect and hopefully will help prepare you well for this exam. Okay, so 1 and 2, we're going to use this computer output. 1 wants you to identify slope. So I first looked to see which options had the right slope value. That was only A and B. And then I tried to find the difference between A and B. The one that set A apart was the word predicted airfare. So for every 1 increase in X, what happens to our predicted Y? Number 2, which of the following best interprets S? S is our average difference or distance between our observed values and our predicted values. All of the numbers for S are correct, so we have to go through and find which one is closest to the to our phrases to memorize, and that is letter C as in Charlie. So we have the word typically, which we're always looking for, and then we have that it's the distance or the, well, it doesn't use difference or distance, but it says that the airfare is about $20 away from the predicted airfare. So actual airfare is about $20 away from predicted airfare. So that's essentially what I have written here. Number 3 is asking about R. I just wrote a note to myself before I even answered this that R is strength and direction of the relationship. So A is describing R squared, B is describing slope, C is weird. I don't think we've talked about any reciprocals in this class. D is true and E is false because correlation doesn't have units. So D as in delta for 3. 4 is C as in Charlie. So this one is one where we have to really pay attention to what they're telling us. So all of them start with sum of the squared differences, but we are looking for what is closest to sum of the squared residuals, which is the difference between y and y hat. So on this first one, it says it's the difference between y and the mean of y. So they're saying that this is, or what this is describing is y minus y bar, the mean of the response variable. Well, no, we're looking for the predicted response variable, so it can't be A. This one is the difference between the observed values of X and the mean of X. So this is X minus X bar, so that's definitely not true. The difference between the observed values of the response, that's Y, and the predicted value of the response, that's y hat. D, the observed value of X, subtract the predicted value of X, which would be X hat, that's a no. And E, the sum of the differences between the predicted X and the mean of X. Yowzas, that's not even close to being true. So it's C as in Charlie. 5 is A as in alpha. So I identified the relationships that I saw. Overall, if you look at the graph as one piece, you have a positive association. But if you break this down into the 2 different shapes, these have negative associations. So considering each variety separately, so that means what I have here, I have circled the O's and I have circled the X's. There is a negative correlation between X and Y. Yes, that is true. Considering both varieties together, there is a negative correlation. That is false. Together is positive. Considering variety X only, there's positive correlation. Nope, that's negative. Considering O only, there is a positive slope. Nope, that's negative. Considering both together, there is a negative slope. Nope, that's positive. So it has to be A as in alpha. 6, which of the following is true about the circled point? Okay, so A, the standardized score for the student's GPA is positive. So the standardized score is how far away from the mean a data value is. And we learned in chapter 1 that the mean would be the center of the data. So center of the data is here. This guy is below the mean, so that means that his standard deviation would be negative, which means his standardized score is also negative. So standardized score is how many standard deviations away from the mean. This guy, we want to think about the mean as being the center. This point is below the center, so it would have a negative z. B, if we use the line to predict the student's score, would it make a prediction that is too low? No. Remember that this line is all the y-hats. These are all of the y-hat values that we could get. This is our actual value. This is our y-hat. So if we are making a prediction for this GPA, our prediction is higher. It's too high, not too low. C, this student's residual is positive. Nope, it's negative. If we're doing y subtract y hat, y is smaller than y hat, so you're going to get a negative. Another way to remember that is that these points are underneath the line. Underneath the line means negative residual. Above the line means positive residual. D, removing this data point would not change the correlation between SAT, math score, and GPA. No, R would increase. If you take that point away, R is going to increase. Typically, if you take away a point or add a point, R will change unless it is very close to the regression line. So in most cases, unless it's close to this line, your R will probably be affected. So it has to be E. Removing the student's data point would decrease the slope of the line. So I personally think if we removed that, this line would change a little bit. I'm exaggerating the change. I have it highlighted. This, the slope of this line is flatter than the slope of this line. So I think that it has to be E. If I wasn't sure, I feel confident that A through D is true. So I feel confident that A through D is false, which would mean that E is the one that has to be true. Next up is 7. This relates really well to your overview. This right here. And R of 0 just means there's no linear association, but something that looks like this has very strong association. So if we look at this residual plot, even though the residual plot, even though this is a residual plot, we still have a very clear pattern. So what does this residual plot tell you? The residual plot confirms the linearity of the relationship. No, definitely no. If the relationship was linear, you'd see random scatter. B, residual plot does not confirm nor rule out linearity. No, this definitely means there's a non-linear relationship. C, the residual plot suggests that the relationship between speed and fuel consumption may be linear. Nope. This tells you not linear. Definitely not linear. Definitely not linear. The residual plot clearly indicates the relationship between speed and fuel consumption is not linear. Yes. And then E, I don't even need to read because I'm so sure about D as in delta. 8, we have this thingy-doozle, this line, which of the following statements must be true? Okay. For each 1 point increase in performance, there will be, the raise will increase on average. No, not on average. For every 1 point increase in performance rating, the predicted raise will increase by 1,400. So this guy's a no. No way. The actual relationship between salary raises and performance rating is linear. Well, we can get a regression line, but it not be a linear relationship. So we would need to see R in order to be able to make this statement. Or the residual plot. We would need to see a residual plot actually. I would want to see a residual plot. Or R, because you can't calculate R if it's not linear, but a residual plot would make me feel better. C, the residuals for half the observations in the data set will be positive. No, we don't know that. It doesn't always work out that half of the data set has positive residuals and half of the data set has negative residuals. So no. The correlation between salary raise and performance rating is negative. No, because the slope is positive. The mean performance rating is 1.2. If the mean performance rating is 1.2, then the mean raise is 3,800. Okay, that's a doozy. So what they're saying is X bar is 1.2. So if we wanted to find Y bar, we would plug this into the regression equation. So we plug this mean of X into the regression equation, and that gives us 3,800, which would have to be the mean of Y because this point is on the regression line. So if X bar has a predicted value, if X bar is 1.2, that means that whatever the predicted value is has to be Y bar, because whatever matches X bar is Y bar. So for this value, Y hat and Y bar are equal. I don't feel like I'm explaining that adequately. I apologize. What we know for sure is that this point is on the regression line, and there's only one value that goes with X bar because it's a straight line, it's a function. So the only value that matches with X bar would be Y bar. So Y hat is always on the regression line, which means if you plug X bar in to find Y hat, it has to be Y bar. It has to be the mean of Y. So in this case, it is echo. Okay. or you could use deduction. And I feel very strongly that D is not it. C, I can see that would be that would be a contender, but it won't. If you look at some of the residual plots like this, not residual plot, I apologize. If you look at this regression line in this review, half of the points are not above the line and half of the points below. There are more points below the line in this regression, and regression is still appropriate. So it's not always true that residuals for half of the observations will be positive. These two things I feel pretty good about as well. Okay, 9 through 10 wants you to find a predicted height and find a residual. I don't feel like there needs to be very much discussion there. So I'll just show you my work. Those two answers are delta and beta. Okay, now we're into the free response. Hopefully, if you had done this after you got your phrases to memorize, after you got this guy, it made this free response section much easier to manage. So we have, we're looking at the relationship between the height of a tennis player and their fastest serve speed. We want to know if there's a relationship between height and serve speed, and what we're seeing is there appears to be a relationship. It seems like in general, the taller you are, the faster your serve speed is. So A, describe the relationship between height and fastest serve speed for these tennis players. So notice on your phrases to memorize, if you're asked to describe the scatter plot, describe the association, describe the relationship, you're using this sentence frame. If I want to know strength, strength is going to be this R value, and this is a moderate R value. This is moderately strong. So I have that here on my paper. Moderate association is 0.50 to 0.79. So there is a moderate positive linear relationship between height and fastest serve. In general, as height increases, fastest serve also increases. B, write the equation and define any variables used. So that is exactly what we have here. If you're ever asked to write the regression equation, you just want to make sure that you always define x and y hat, and they're just being nice and reminding you to do that. So this is our regression equation where x is height and y hat is predicted fastest serve. You could have also done like the hat with fastest serve, and then 6, 8, 8, 1, 8, 4, 9, 8 height. I don't really prefer that method, but you can use it, and I wouldn't mark you wrong for that either. And then interpret R squared, so I could just pull directly from this. About 27.7% of the variation in fastest speed can be explained by the player's height when using the least squared regression line. That's wrong. Fastest serve. Same data. Predict the fastest serve of a professional tennis player who is 1.7 meters tall and comment on the reliability of this prediction. So I'm using this section where we answer or repeat the prompt, and then we can use this phrase to memorize. So this prediction is not reliable, so I repeated this question and answered it. This prediction is not reliable because we are extrapolating. We do not have data for players shorter than 1.8 meters. So we don't know if the linear trend continues for those players. So I didn't follow the sentence frames exactly because I didn't want to have to estimate what this height was and what this height was, because it doesn't land on a nice value. So I did the best that I could to use that sentence frame as closely as I could. So no, we don't have data for players shorter than 1/8. So we don't know if the linear trend continues below that. E, what is the value of the correlation? And interpret this value. So this is going to seem redundant or repetitive. Now we're on this interpretation, and the only difference between part A and this part is the word linear is given. So essentially, my answer for A and my answer for B, and not essentially, like they're exactly the same. So my answer, I just want to say that one more time, my answer for A and my answer for E are exactly the same. And that's okay. Then lastly, calculate the residual and interpret the residual. This player's actual fastest serve is 13.8688 kilometers per hour, less than predicted based on their height. So actual fastest serve, value of the residual with units, less than, do not put the negative on there. Don't put the negative on there. I'm going to say that one more time. Don't put the negative on. Less than predicted. Okay, and our last problem is studying outbreaks of locusts in Tanzania. They give us the regression equation. Interpret the slope of this line in context of the problem. For every 1 inch increase in rainfall, and then I realized that I needed to specify during the wet season. So for every 1 inch increase in rainfall during the wet season, the LSRL predicts that the relative abundance of adult red locusts decreases by about 0.12. B, they gave us the correlation. If the rainfall were measured in centimeters rather than inches, how would correlation change? Correlation would not change. The amount of rainfall is the same. The way you describe, or the measurement you describe the rainfall with, is different, but the amount is the same. So correlation does not have units. The relationship between rainfall and abundance of locusts will not change if the rainfall were measured in centimeters rather than inches. And you could say because it's the same amount of rainfall. Changing the units does not change the amount of rainfall. Maybe I'll say that. Because and notice, because this is a formal response, I'm not writing B/C. I'm actually writing the word because. Because changing units does not change the amount of rainfall. And then lastly, they give us the residual for predicted Y. for a given x, and they want us to find the actual y. So I set this up with my 4 things that I need. X, y, y hat residual. They gave us x. We can calculate y hat, and they gave us the residual. So we use this equation to solve for actual, and then we interpret, or we make a statement. I don't know if this part is necessary, but I would add it in. So we found actual y, and then the statement is when the rainfall was 3 inches, the actual relative abundance was 7.59 on a scale from 1 to 10. I don't know if this is required. It probably is, because this adds context to the problem. So we're going to have to remember to add that in. When you are calculating a residual, we may need to add in context. Darn it. I apologize. So on this one, they didn't specifically say interpret your residual, but we did. So I should have, oh, I did. Okay, so we needed to interpret that residual. All right. So if they ask for a residual, it's probably always best bet to interpret it. Okay, that's it. We are on to Unit 2. Just kidding. Holy moly, guys. Do I even have my head on straight? So this is our last review for this unit, and this is the difficulty level. So let me make my face big. This is the difficulty level that you should expect on your exam when I see you. So these problems, I felt like were on the easier end. This free response, I believe, is on the easier end of the free response problems. This free response, these 2 free response, this is the difficulty level that you should expect on your exam. So if you haven't done it yet, know before going in that this is what you should expect to see. The other one is an easier version. You're going to get a harder version, so do the best that you can to figure things out before you watch the solutions video, because that's how you're going to get the most out of these. Okay, love you guys as usual. If you have questions, please email me. And I say this a lot, and I'm just hoping that one time you guys will believe me, but please email me and ask questions if you have them. I promise you, I want to help you. I want you to be successful. Your success is my success. So why wouldn't I want to do everything that I can to make sure you're successful? We are on the same team. It's not me against you. It's us together against AP Stats. So please trust that I want your success, sometimes more than you want your success. So please email me and at least give me another shot to explain. I'm wondering maybe if sometimes you guys don't ask me questions because you're like, well, I didn't get the first time you explained it, so why am I going to get it if you explain it another time? But maybe I can figure out a way to say it differently so that it reaches you. So please, I'm begging you, email me if you have questions, and I'm happy to help you. Okay. Love you guys.